Hello students, today I am going to discuss chapter number 9, that is current electricity. Now there are two types of current, alternating current and direct current. Direct current is a current of constant magnitude flowing in one direction, while alternating current does not have constant magnitude and direction and it changes its polarity. Direct current is denoted by D dot C and alternating current is denoted by A dot C. We can represent this alternating current with a sine wave also. So this is a symbol for your sine wave. Now sources for direct current are your cell, battery, while the electricity which we use in house and factories uses your alternating current. Now what are the sources of direct current? We are familiar with cells used in torch to light up its bulb. So the cells are the source of your direct current. You can see in a figure I have drawn a cell. Let us say this is the positive terminal of a cell and this is the negative terminal of a cell. Now when we have connected this bulb to a cell with the help of the metallic wire, and we have attached a switch also. Now when we on the switch, what will happen? The current will flow through the cell and the bulb will glow. Now remember, when I switch off the cell, then what will happen? The current will not flow through the bulb and the bulb will not glow. So bulb will only glow when the current is drawn and the current flows through the cell. You can see here from figure, this is a brass cap of a cell and this is the positive terminal. Here you have negative terminal of a cell and the base is made up of a zinc case. The switch is attached and the bulb is also there. Now when the cell gets discharged, it stops giving current and becomes useless. And remember, the current flows from positive terminal of a cell to its negative terminal. Suppose you have positive terminal here and this is negative terminal. So current will flow from positive terminal to negative terminal. So I am writing here that current, this is very important to remember, that current flows from positive terminal to negative terminal. And students, also remember this thing, that in cell chemical energy changes into electrical energy when it sends currents in a circuit. So what is the energy transformation? Your chemical energy to electrical energy. Now we will discuss kinds of cell. There are two types of cells, primary cell and secondary cell. First I'll explain you what are primary cells. Now primary cells are those cells in which chemical reaction is irreversible. I have told you students that in a cell chemical energy changes into electrical energy. So in primary cells the chemical reaction is irreversible. Mean to say, once the cells are used, we cannot use them again and again. And these are use and throw types of cells, that is, they cannot be recharged. Remember, from primary cells we get weak current. These primary cells are very light and cheap, and examples, depending upon the sources of material used, we have different types of primary cells. That for example, you have dry cell, Daniell cell, Leclanché cell, all are examples of primary cells. That is, these cannot be recharged again and again once used. Then you have secondary cell. Second type of cells are secondary cells. Now secondary cells are those cells in which chemical reaction is reversible. Means in this case the chemical reaction they can be recharged again and again. Now they can provide low as well as high current, and they are heavy and costly. Now example for secondary cell are lead accumulator and lithium hydrogen battery. Remember students that these secondary cells, they can be used for long period of time. Why I'm saying for long period of time? Because as I've said that they can be recharged. That is, once the chemical energy is used, we can charge them and again we can use them for next purpose. So again I'm concluding that in primary cells the reaction is irreversible and chemical energy is converted into electrical energy when current is drawn from it. Remember students, when current is drawn, then only we can convert chemical energy into electrical energy. While in secondary cells, when these cells are the chemical reaction in secondary cells are reversible, that is, it can be recharged. So electrical energy converts into chemical energy when current is passed through it, and opposite, chemical energy is converted into electrical energy when current is drawn from it. So remember, always remember that in secondary cells chemical energy gets converted into electrical energy when current is passed from it, that is during charging. While electrical energy, dear students, again I'm repeating, in this secondary cells chemical energy converts into electrical energy when current is drawn from the cell, that is during your discharging. While electrical energy converts into chemical energy when current is passed in it, that is during charges. So these cells are your reversible kind of cells. So next topic is electric current. Dear students, we have read that when two bodies are rubbed together, they get charged due to transfer of electrons. For example, if we have two charged body, let us say body A and body B, and they are joined by, let us say, some metallic wire. Now, when the electrons, suppose body A has excess of electrons while body B has deficient of electrons. Deficient means it has less electrons. Now the electrons will flow from body A to body B. So the electrons flows from body having high electrons to body having low electrons. Remember, the body gaining electrons becomes negatively charged, while the body losing electrons become positively charged. So the flow of electrons constitutes your electric current. So we can means flow of electrons constitute your electric current. So students, we can define current as rate of flow of charge across a cross section normal to the direction of flow of current. Remember, current can be defined as flow of charge per unit time. We denote current by letter I, charge by letter Q and time by T. Now, what about units of current? We know unit of charge is coulomb and it is noted by letter C. Unit of charge is coulomb and unit of time is second. So, unit for current is coulomb per second. Another name for coulomb per second is ampere. After name of a scientist, ampere, and it is noted by letter A. It is noted by letter A. So it was asked in a board exams, give a symbol for the SI unit of current. So A is the symbol for unit of current. Remember, again I am repeating, current is the rate of flow of charge. So we can say charge per unit time. That is I is equal to Q upon T, where Q is your charge. And unit of current is coulomb per second, that is ampere. Remember students that current is a scalar quantity. It is a scalar quantity. Dear students, you have to learn this, that in metals the current flows due to movement of electrons. So this is very important, how the current flows through your metals. It flows through the movement of electrons. So electrons are responsible for current in metals. That also free electrons. In board exams last year it was asked which factor is responsible for current in metals. That is your free electrons. In electrons, movement of positive and negative ions constitute your current. That is, your cations and anions are responsible for the current. Now let us say if n electrons pass through a cross section of a conductor in time t, then we can write down charge as charge is equal to Ne. Means suppose you have any conductor and n electrons flows through them in time t, then charge constituted by that conductor will be equal to Ne, where n is the number of electrons and E is the charge on one electron. Now, what is the charge on one electron? Dear students, remember, charge on electron is equal to 1.6 into 10 raised to power minus 19 coulomb. So this is the charge of a electron. So students, again I am repeating the concluding the topic, that current is denoted by letter I and it is charge upon time. Charge we denote by letter Q and time by letter T. Unit for current, we know unit of charge is coulomb and for time it is second. So coulomb per second is the unit of SI unit of current, and this coulomb per second is also known as ampere after name of a scientist denoted by letter A. Current is a scalar quantity. Then in metals, electrons are responsible for constituting a current, and in electrolytes your cations and anions are responsible for constituting a current, your positive charged ions and negatively charged ions. Then what about total charge? If n electrons flows through the conductor in time t, then charge will be equal to Ne, and we know charge on one electron is equal to 1.6 into 10 raised to power minus 19 coulomb. So if I put this value here, I can get I will be equal to Ne upon T. So you can use these two formulas for solving the numericals. So this was all about your electric current. Today we have studied what do you mean by direct current, your alternating current, types of cells, primary cells and secondary cells, and electric current. So electric current is the rate of flow of electric charge.